In this video, we get to take a look at packet analysis with a really important first step, and that is to get the packets so that we can analyze them. So if we have captured the data at some point in our network, for example, here or a specific interface, I'm talking about taking all the packets and then copying them over to a separate location, we can then take a protocol analyzer, such as Wireshark, and actually see all the packets. And one of the cool things about using a protocol analyzer like Wireshark is that the packets don't lie. If you're capturing traffic from this part of the network, for example, and then you look at those packets are telling you literally what's going back and forth over that link. Now, as far as getting those packets and forming them into a file for packet analysis, let's take a look at some options for packet captures, and a few of those options we've taken a look at previously. One would be to use a tap. So we could actually put a device in line here, for example, that's collecting the data and then sending that off to our device running Wireshark, or we're capturing that file with an inline tap. That's certainly one way of doing it. Another option is we could use port mirroring. So we could take, for example, traffic that is coming into or out of gig 1/1. If we want to capture all that traffic, we could take that traffic and then ship that over to another port. So for example, let's say we have the protocol analyzer software with Wireshark running on port 3/3. So we could take the traffic, copy every packet over to port 3/3, and there we'd have our protocol analyzer sitting to collect that data. So here's the network interface card, and then with Wireshark, we simply tell it to run and capture the data right here. Or we could have other systems that are collecting that information and placing it into a file. So with that concept of port mirroring in a Cisco environment, it's called SPAN, Switch Port Analyzer. Or instead of doing port mirroring, we could actually mirror all the traffic within a VLAN. So we could take all the traffic, for example, in VLAN 1 and then replicate that over to another port. And yet another option is called ERSPAN, which stands for Encapsulated Remote Span. And that's where we take the traffic, for example, from VLAN 1 or from this port or that port or this port, and then we encapsulate it, and then we can route that encapsulated traffic over to our management computer. And when that happens, it's a lot like a tunnel. So we take the traffic that we're capturing locally or mirroring locally, and then we encapsulate it, then we can ship it down, for example, to a destination. This would be using a GRE tunnel, which stands for Generic Routing Encapsulation. And then when that traffic shows up with a PC here, if that's our management station, and then all that copied traffic that's coming into this PC is going into our protocol analyzer like Wireshark that's running, where we can see exactly what's happening up here on this network. There's also a flavor on Cisco environments of SPAN called RSPAN, and that's remote span, where we have, for example, 2 switches with a trunk, and we're going to capture the data that's happening here, for example, on a port or on the VLAN, and then ship it over to a second switch where we could then have a destination device like our Wireshark machine running right here off this second switch, which is then being sent the data. And that's referred to as RSPAN. So ERSPAN is routing the data to a remote location that's not local, and RSPAN is sending it over to another switch. And then just normal span is copying, for example, like here, traffic from 1/1 and shipping it over on the same switch to a different port like 3/3. So to help reinforce that, I'd like to do a demonstration of setting up a simple port replication, or in a Cisco world called SPAN, here on our switch in our topology. And then we'll also take a look at a protocol analyzer that's currently running down here on the client PC to help reinforce both parts regarding the packet capture, in this case with SPAN, and also packet analysis with Wireshark. So back in the lab environment, I've got a little notepad document that's going to walk us through this configuration. So on this Cisco Catalyst switch, these commands right here take us into configuration mode. That's the config T part. Then we're going to create a monitor session number 1 and saying, hey, we want to look at the traffic going into and out of gig 1/1 on the switch. And that's what both represents, the inbound and outbound. And then we want to take copies of each and every one of those packets and replicate them or mirror them over to gig 3/3. And on port 3/3, that's where we'd have the device that's collecting that captured information that would be running some type of an application like Wireshark that could then be used to look at that data. So I'm going to take this part right here, copy it to my buffer by right-clicking, clicking on copy, and then going to the right device, which is switch 1. And here on switch 1, I'm going to paste that in. And boom, we've now set up port replication. So now traffic involved with port 1/1, gig 1/1, whether it's inbound or egress traffic on that interface, is going to be copied over to 3/3. And we can verify our config by doing a show, monitor, and a question mark, and session, and we want, how about session all? There we go. So we'll type in all. This basically says we're copying the traffic that goes in or out of gig 1/1, and we're going to ship it over to gig 3/3. So here on switch 1, we've now set up replication of traffic inbound and outbound on that interface. going over to port 3/3. So in our topology, I don't have a Wireshark device hanging up at port 3/3, but that's where all those packets are being copied right now. So the other half of that regarding working with and using a protocol analyzer, I'd like to go over to Client NUG. So I'm going to open up Client NUG, and here on Client NUG, I'm going to minimize the command prompt, and I have running Wireshark. So here in Wireshark is an example of a tool that can do protocol analysis with a capture file. We're looking at a packet capture file, packetcapture.pcapng, which is on the desktop here of this Windows client machine. Then we can go through and see all the packets included as part of this packet capture. So here's an OSPF hello message. Here is a DNS request, and this is being made from our client at 10.10.050 to the IP address 23.1.2.100, looking for name resolution for nav.smartscreen.microsoft.com. And if we open up the DNS request here, we can see that as well down in the details. So there's the query looking for that specific name, and it's looking for an A record. That's an IPv4 record. And because the server that this is going to, which is 23.1.2.100, isn't configured to go out to the public internet and actually do that recursive lookup, we're not getting a response back from the DNS server for that because the DNS server doesn't know. But in either event, we now can see what's happening here because we have a packet capture of all those files and using Wireshark to analyze it. So now that we've taken a look at some options regarding port mirroring and packet capture, and also reviewing the idea of a protocol analyzer like Wireshark, in the next video, I'd like to put you on a hands-on lab that can help us in reinforcing many of the concepts that we've talked about and discussed in this set of videos. So when you're ready, I'll see you in the next video as we take on the hands-on lab.
Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.